Hello everyone! Today we'll talk about the solution to the problem longest strictly increasing or strictly decreasing subarray. This is an easy problem, so there's not much to talk about really, but I'll find some points that I want to touch on. First of all, we have this word subarray. Don't confuse a subarray with a subsequence. The problem of longest increasing subsequence is a famous problem. It has an n log n solution, multiple n log n solutions. It's good to know them. It's good to think about that problem. But it's a harder problem than finding a subarray that's increasing, because a subarray is increasing, well, we can just see neighboring elements and there are no choices of whether or not to skip a given element. In particular, we are of course interested in situations where two neighboring elements, the right one, so the next one, is bigger than the previous one for increasing, and you can simply go through the whole array and check if the next element is smaller or equal to the current element, then at that point we end our current subarray that's increasing. And we'll of course maintain the length of that subarray, so we can just do it, go through the whole array. At some points we reset the length to 0, and that's all that we need to do. So that was one thing. Another thing is that we have either strictly increasing or strictly decreasing. It's obvious that those are very similar problems, so it's good to find a solution, find some way of writing the solution that will not require you to essentially copy over a lot of the same code and just changing like a few characters. So that's also something to keep in mind when you are solving this problem. It's not necessary to solve it, but it's good to think about stuff like that. And one way of doing that is to write only the version for the increasing case, and then simply try to find the strictly increasing subarray of both the numbers and the numbers in reverse. In Python, one way of reversing a list is to use the slice notation, which will be double colons and -1. Of course, this notation, if you're not familiar, this is start, this is end, so the last element that should not, so the first element that should not be included, and the step, so starting with start, we will be stepping by step. And if you leave some of those empty, then they are the default. So essentially here for negative step size, we'll be starting at the last element, ending at the first element. So this is just a way of writing concisely a copy that's reversed. And we want the maximum of those two cases. And a single case, as I mentioned, will just be maintaining the current length and the best length we've seen so far. And we go through all the pairs of elements. So for instance, we can go from indices starting from 1 up to the end of the list and compare the -1 to I. So I minus 1 to I, those are the two elements. And of course the case that we want to have, since we care about strictly increasing, of course we could also check strictly decreasing. This will still work because we just have to look from both sides. We compare those two elements. And now if those two elements are not equal, or they are not in the correct order, then we have to reset our counter, otherwise we can increment the counter. And this is a pretty pointless exercise, writing this in a pretty weird way. So you can take our current length, increase it by 1, and multiply it by this expression. So this expression is a boolean, whether or not this is true or false. And true is the same as 1, it's an integer 1, and false is the same as 0. So it's either 0 if this is false or 1 if this is true. So this will zero out the counter for us. We remember the best one, of course, and return the best plus 1, because we are here counting only the non-trivial, so the number of pairs of neighboring elements that are correct. We are interested in the number of elements, that number is 1 larger. So this is a simple problem. If you think this is classic Python, this is something weird, but also good to know that something like that can happen. And of course the fact that we have those two directions to have a single function and use it twice to solve both the cases in our problem.